Hi guys, finally we need to talk about the properties of alpha. How fast it travels, is it ionising? Now I've sent you a link on BBC Bitesize, and it did actually, I didn't mean to, but it did actually have it written on, had this table, which is something you should have learnt in GCSEs. So alpha, we know, has a range of 3 to 5 centimetres in air. We know it's highly ionising, though we need to describe what that means. We know it can't pass through paper. Do me a favour, we need to do a whole thing on the electrical field and magnetic field deflection, but we're going to wait on that. Okay, so this was the site I gave you. You might remember your physics teacher, if you had one, talking about alpha not passing through paper and beta. We've seen big particles giving off alpha, but it can't pass through paper. Okay, it's a type of radiation. It's quite good. There's a nice video about the speed actually at the bottom, which you might remember too. This is them racing. The alpha particle, 2 protons, 2 neutrons. The beta particle was very fast, and the gamma wave went at the speed of light, as it were. Now you need to research obviously about the speed and the range and ionising power. I might just describe ionising power for you. You know what an ion is. An ion is a charged atom, okay? If we had helium, normal helium with 2 electrons floating around it. So there we go, let's make helium. And it's got 2 electrons floating around it, okay? It's not an ion because it has a charge of 0. Okay? If we took away an electron, it would have a charge of +1. Because it's lost its negative charge. If we took away another, so it becomes an ion. If we took away another electron, and we were just left with a nucleus, like an alpha particle, I should have put a +1 there, the charge becomes +2. And it becomes an ion. Knowing that, okay, if I had an alpha particle, and it flew towards an atom, and this atom had loads of electrons floating around, how likely is this alpha particle to take one of these electrons away? Not likely to give it any electrons, but it might take one. It might take one because it has quite a high relative charge, so it's highly ionising. It's very likely to strip one of the electrons away, depending on how close it was to it, I suppose. Okay, so you would say an alpha particle is highly ionising. You'd have to describe what ionising means. I've said it too many times now. However, will it make that atom into an ion? Will that atom, when the alpha particle's gone, have a charge that it didn't have before? Okay. There's my table again. My alpha particle is highly ionising compared to my beta particle. Next week we're going to go more onto the beta particle. There's some uses of alpha that are quite good. I found a website with 10 on. It's used in cancer treatment. It's used, it was used to poison someone, to be fair. What was his name? I might put a link into the story. Litvinenko. It's an interesting story, but I won't go into it now. The one I'm going to look at is a smoke detector, okay, and fire alarms and things like that. And the way that I'll send you a link to that one. The way we're going to do the fire alarm is, I'm going to just actually, no, I will just draw it. If I had some americium or americunium, okay, and it was given off some alphas. Yeah. And if I had a receiver measuring how many alphas it got per second, say it received 5 per second. Okay. If there was a load of smoke, because alpha is stopped by paper and smoke, what would happen to this number? This number would go down. If the number got too low, there'd be smoke in the way. I would set off an alarm if that number got too low. And that's how some smoke detectors work. Okay, it's also because it gets hot, and this is very complicated, so I don't really want to go too into it, but there's if you're bothered by it, it will create something called a radioisotope thermal electric generator. Okay, and these can be used, okay, basically the heat released from the decay we can turn into electricity with no moving parts using thermocouples and very complicated things. And they put these in satellites and things like that. I found a Wikipedia page on it. Okay, there you go. It gets rather complicated of it. But they put it in spacecrafts and things like that to get electrical energy out of it. There it is. There's one. A pellet of, I don't know what that one is. Plutonium? No, it's not uranium. Let's have a look. My periodic table. Plutonium, there we go. So this is a pellet of plutonium used in the Cassini and Galileo missions. Okay, it got quite hot, and the heat energy, the difference in the heat energy was used to get an output of electrical energy. Okay, and that's what they use in satellites. So apart from me telling you how fast they are and you need to research some bits of it, I can't just give you the answers in videos, but read the Word document and you should have got it. I hope everything's okay. I will chat to you soon. Ta-ta.